Let's explore the fascinating world of logic gates. We will uncover the principles of positive and negative logic conventions, which are fundamental in digital electronics. Understanding these concepts is essential for anyone working with digital circuits, from designing simple electronic gadgets to developing complex computer systems. Let's start by contrasting the high and low signals with positive and negative logic. A logic convention defines how voltage levels are mapped to logical states, 0 and 1, in digital circuits. This mapping determines how we interpret the signals in a circuit. Typically, we deal with two voltage levels, a high voltage and a low voltage. The logic convention tells us which of these voltage levels represents a logic 1 or a logic 0. Understanding logic conventions is crucial for correctly interpreting the behavior of digital circuits and systems. In positive logic convention, a high voltage level, often 5 volts, is defined as logic 1, and a low voltage level, typically 0 volts or ground, is defined as logic 0. This is the more intuitive and commonly used convention. In simpler terms, if you see a higher voltage, you interpret it as a true or on state. Conversely, a low voltage indicates a false or off state. Negative logic convention is the opposite of positive logic. Here, a high voltage level like 5 volts is defined as logic 0, and a low voltage level such as 0 volts is defined as logic 1. While less common, negative logic can be useful in certain situations, particularly when dealing with active low signals. The key thing to remember is that a lower voltage means true or on, while a higher voltage means false or off. Let's compare the truth tables of an AND gate under both positive and negative logic conventions. Under positive logic, the AND gate behaves as expected. The output is 1 only when both inputs A and B are 1. Otherwise, the output is 0. Now, let's examine the same AND gate but interpreted with negative logic. Notice that the truth table is flipped. With negative logic, the output is 0 only when both inputs A and B are 0. Otherwise, the output is 1. Now, let's compare the truth tables for an OR gate in both positive and negative logic. In positive logic, the OR gate's output is 1 if either input A or input B or both are 1. The output is 0 only if both inputs are 0. Now, considering negative logic, the OR gate's behavior changes. The output is 0 if either input A or input B or both are 0. The output is 1 only when both inputs are 1. Here's a key observation. In negative logic, an AND gate effectively behaves like an OR gate, and conversely, an OR gate behaves like an AND gate. This is because the roles of 0 and 1 are reversed. This duality can be useful in simplifying circuit designs in certain situations. Understanding positive and negative logic conventions has several practical applications. In circuit design, it aids in interfacing different systems and selecting optimal logic families for specific tasks. Also, it is critical in signal processing, particularly when dealing with active low signals and control systems commonly found in embedded applications. Both conventions merely represent the same physical circuit behavior, but through different interpretations. The choice depends on design needs and context. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.